Hello good people, I'm going to start talking about organic chemistry. The initial hurdle with organic chemistry is that it comes with its own language. Beyond the new words that we need to learn, we also need to get comfortable with the way we depict compounds. Here I have drawn 6 organic compounds, and as this course progresses, you will hopefully get more comfortable with all of these lines and squiggles, and more importantly, you will know what they mean. These 6 drawings are representations of compounds that you might be familiar with. On the top left side, we have acetylsalicylic acid, the active ingredient of aspirin. Beneath, we have the structure for ibuprofen. To the right, the structure that represents paracetamol. Above it, we have lauric acid, which can be found in many cosmetics. Above it, we have glycine, an amino acid that is present in many proteins. And to the right, we have heme B. This complicated-looking molecule is found within the hemoglobin protein, that in turn is found within our blood cells and is responsible for carrying oxygen around our body. Before we dive deeper into deciphering these structures, let me deal with some of these new words that we need to be comfortable with. So firstly, what is organic chemistry? The term organic suggests that organic chemistry is somehow connected to living organisms. And that is absolutely true. Living organisms are made up of organic compounds. And from a historical perspective, organic chemistry used to deal only with substances that were obtained from living matter. In other words, substances that we could get from plants and animals. This is still true today. A lot of organic compounds are derived from living matter. However, a large percentage of organic compounds that we make in labs has its origin in crude oil. More on that later. It turns out that most of the substances obtained from living matter were made up of just a few elements: carbon, hydrogen, oxygen, nitrogen, and every now and then sulfur and phosphorus. The important thing to note is that of these 6 elements, carbon was almost always present. So the current definition of organic chemistry is that it is the chemistry of compounds that contain carbon. Why is carbon so special? Why is it present in so many compounds? Well, carbon is capable of catenation. This is the ability to form long chains of its own atoms. This means that while I can link an almost infinite amount of carbon atoms, I cannot do the same to hydrogen, oxygen, or say nitrogen. That being said, hydrogen, oxygen, and nitrogen still have a very important role to play when it comes to organic chemistry. So let me look at some of the basic building blocks in organic chemistry. The basic building blocks include these 4 atoms: hydrogen, oxygen, nitrogen, and carbon. Let me bring in their Lewis dot structures. Recall that the number of single unpaired electrons represents the valency of the atom. The valency also indicates the number of covalent bonds that these atoms can form. And here are our options. When it comes to hydrogen, I only have one choice. A hydrogen can only ever form a single bond. In case of oxygen, there are 2 options: an oxygen with 2 single bonds or an oxygen with a double bond. Nitrogen has 3 options: nitrogen with 3 single bonds, nitrogen with a single bond and a double bond, and a nitrogen with a triple bond. Carbon with valency of 4 has 4 options. I could have 4 single bonds, 2 single bonds and a double bond, 2 double bonds, and finally a single bond and a triple bond. As you proceed with the topic of organic chemistry, keep these 10 building blocks in mind. They are the main pieces that we can play with when creating compounds and drawing their structures. That is all for now, and I will see you on the flip side.